As I mentioned in the last video, in order for your muscles to contract, you're going to need a ton of ATP energy. So we have to talk about where this ATP comes from and how we can train our muscles to do what we want them to do. So first of all, to fuel our body and to make that ATP that we need for muscle contraction, there's a few sources we can use for energy. And these sources are used in a certain order, typically in your body. The first thing we could use is glycogen, which is the carbohydrates or the sugars that are stored in the muscle. So there's always a small reserve of glycogen or sugars in your muscle, and they get used up first. So in this graph, like you can see the green here, this is the glycogen stored in your muscles. This is going to be what's used primarily at the beginning if you're going to be doing some exercise, and it'll be used up first. Second, there's some triglycerides or some fats that are stored in your muscle that'll be used second. After these energy sources are exhausted, then your body will turn to energy from your blood. Okay, so first we will also have glucose or sugar in your blood that's going to be used up first, and then your body will follow up by using any fatty acids that are in your plasma. Now, it's not like we use them all one at a time. They're all used in conjunction when you're burning energy, but this is typically the order that they'll be used in primarily. Now, how does your body make ATP for muscle contraction? Now, the first thing is in your muscles right now, at all times, you have about maybe 4 to 6 seconds worth of ATP just chilling in your muscles waiting to be used. All right, so if you start doing a workout, within about 4 to 6 seconds, all the ATP that's been stored in your muscles gone. Now what's your body going to do? The second thing your body's going to do is use something called the creatine phosphate pathway. Okay, so here's how this works. ATP, if you remember, ATP is a molecule that has 3 phosphates. Okay, so the ATP molecule, it's a sugar, and there's 3 phosphates attached on there. Where the energy comes from in ATP is one of the bonds, one of these phosphates gets broken off, and that provides a burst of energy. So basically what happens is ATP has 3 phosphates. One of the phosphates gets chopped off over here, and what you end up with is ADP plus the phosphate that fell off is now gone. So if we want to make more ATP, something we can do is use this molecule called creatine phosphate. All right, creatine phosphate has one single phosphate stuck on it. And what can happen is this creatine phosphate can give away its phosphate, and now it can reconvert ADP back into ATP. All right, so creatine phosphate can give away its phosphate. Now you may be wondering, what the heck is creatine phosphate? You can get this from eating meat. Meat contains natural source of creatine. Also, your body always makes a little bit of creatine phosphate. You make it in your liver and you make it in your kidneys. So, you have enough creatine phosphate in your muscles to be able to make enough ATP for about 15 seconds at a time. So it's not like it's a very long-term energy source. Creatine phosphate is also just a quick burst of energy. So like if you're doing a quick sprint for just like 15 seconds, or you need a quick burst of energy to lift up something heavy, creatine phosphate can give you that quick boost of ATP that you need. Okay, so far we said there's about 4 to 6 seconds of natural ATP in your muscle. If you need a quick boost of ATP, your body will use the creatine phosphate pathway, which is just a short boost. Now, the third thing that your body could use to make ATP is cellular respiration. Cellular respiration uses glucose from your food that you eat, all right, sugar, plus oxygen that you're breathing, okay? And it uses the glucose and oxygen to make a lot of nice ATP. So cellular respiration requires oxygen. So this is what we call an aerobic process, meaning it requires oxygen. Cellular respiration is amazing because it only takes one glucose and you can make about 32 ATP from one glucose molecule. That's a really good return on your investment. That would be like if you invested $1 into your bank and they gave you back 32. Like, that's amazing. I'll take that all day. So cellular respiration, it's a good way to make ATP. And it can be sustained for a long time. So you can make, as long as you have oxygen and sugar in your body, this can go on forever. The negative thing about cellular respiration, it's very slow. So if you need a quick boost of ATP, if you're going to go for a sprint or if you're like powerlifting, this is not a great way to get that quick, fast boost of ATP that you need. The final way that you can make some ATP is through a process called fermentation. This process is an anaerobic process, meaning there's no oxygen needed. There's no oxygen required for fermentation. Now, during fermentation, again, this is going to give you a quick boost of ATP. So if you're doing something that requires a super quick boost and you've already used up your creatine phosphate, cellular respiration is not fast enough, then your body will do fermentation. The problem with fermentation is after it's done, there's a waste product that builds up called lactic acid. So lactic acid will build up in the muscle. And sometimes what can happen if there's lactic acid is it's going to lead to soreness. So if you feel that muscle soreness after a quick burst of sprinting or whatever, all right, it's due to the fermentation process. Now, your muscle fibers come in two different forms, and you can actually train your muscles to be the form that you want, which is kind of cool. So the first type of muscle fiber, we call it a fast twitch fiber. So just like this sounds, fast twitch, you use this for when you need a quick muscles, okay? If you need to be a sprinter or if you need strength, okay? These muscles are good for strength or like fast sprinting movements. So fast twitch muscle fibers have little myoglobin, meaning there's less blood flow in these types of muscles. Because of there's less myoglobin, the fast twitch muscle fibers are actually usually a lighter color. So in this picture, these whitish ones represent the fast twitch muscle fibers. Fast twitch relies more heavily on the creatine and the fermentation ATP pathways, primarily anaerobic. So if you're a person who's practicing sprinting or powerlifting, or you need those quick bursts of energy, you could train your muscles to have more of these fast twitch fibers. The opposite, the slow twitch fibers. These ones are these darker ones in color. They look darker because there's going to be more blood vessels, more blood flow. Okay, these are more heavily in myoglobin. People who have more slow twitch fibers are the endurance athletes. So people who need to be able to produce a lot of oxygen and really efficiently move oxygen through their body, such as people who maybe like run long distance or swimming long distance or running a lot, or soccer players, things like that. So slow twitch fibers rely more on that aerobic cellular respiration. So like I said, we can actually train our muscles to have one fiber or the other. Someone who is untrained will have about half slow twitch, half fast twitch. Like I said, sprinters who require those quick bursts of energy will probably have much more fast twitch muscles, maybe 80-20. People who are like marathon runners or distance runners will have more of those slow twitch muscles. Someone who's like a power lifter, they're probably going to be more like 50-50, maybe a little bit more of that fast twitch muscle.